Pause the video here and write the equation for the reduction of pentanal. Here's the answer for this example. Because I don't have any hydroxyl groups or C single bonded O's, I would then attack this C double bonded O. This changes pentanal into pentan-1-ol. The sixth type of organic reaction is known as a condensation. It occurs when two organic molecules join together to form a larger organic molecule and also release water. An example is making an ester. If I take ethanoic acid and methanol, now it always helps to draw the functional groups facing each other. They're going to be where the reaction happens anyway. If I react these two together, I can form water by taking either the hydroxyl group off of the acid or the methanol and another H off of the neighbor. It doesn't matter in this case which hydroxyl group falls off and which H falls off. I now have the ingredients for an ester. I have a C, an O, a C, and a double bonded O. This gives me methyl ethanoate as my organic product. Pause the video here and condense but-2-ionoic acid and prop-and-1-ol. Here's the answer for the next example. Because again I have a carboxylic acid and an alcohol, they're going to condense together to give me an ester. This will give me propyl but-2-ionoate as my larger organic and water as my second product. The opposite reaction of a condensation is known as a hydrolysis. A water splits a large organic molecule into two smaller organics. Now, it's important to note that you can only break CO bonds or CN bonds. You cannot break CC bonds in a hydrolysis. They are too strong. Example 1 is taking an ether and hydrolyzing it into two alcohols. Here is methoxyethane reacting with water. I have two CO bonds in this molecule that I could potentially break. With an ether, it doesn't matter. Because I chose to break that one, this carbon will be looking for something exciting to bond with. It lost a functional group, so it will bond with this hydroxyl. The O that's missing a bond will then bond with the remaining H. This gives me methanol as my first product, and ethanol as my second. For the next example, it does matter which bond you break. Here I have an amide. This is N-butyl ethanamide. If I react that with water, I have two options of bonds to break as well. I could break this CN bond or this CN bond. Now remember, hydrolysis reactions are the opposite of condensations. In order to make an amide, I condense a carboxylic acid and an amine. So if I hydrolyze an amide, I need to get a carboxylic acid and an amine back. That means this CN bond is the one that needs to break. The C with the double bonded O will claim the hydroxyl functional group, making a carboxylic acid, and the H will go on the end to make an amine. This gives me ethanoic acid as my first product, and butan 1-amine as my second product. Now that you know all 7 types of organic reactions, you can answer questions like this one. What type of reaction can be done with pentan-2-ol? Or I could ask you to write equations for 2 reactions that this molecule can do. Think about each definition of the reaction type and decide if pentan-2-ol can perform this type of reaction. Pause the video now and make your selections. Here are the answers. Because pentanetol does not have a double or triple bond, it cannot perform an addition reaction. You can remove the hydroxyl group and a neighboring H, so that means pentanetol can do an elimination. You could remove the hydroxyl and replace it with a different functional group. Therefore, it can do a substitution. You could change the single bonded O to a double bonded O. Therefore, you can do an oxidation. You could remove the hydroxyl group and replace it with an H, which would reduce the number of CO bonds by 1. You could condense pentanetol with either a carboxylic acid to make an ester or another alcohol to make an ether. You cannot hydrolyze an alcohol. There are no CO bonds or CN bonds that you could break that would create two different organic products. Have a look at this flowchart on the next page. It nicely and neatly shows how different families can be changed into other families using the 7 reactions that we talked about. It's a great visual, but it's not perfect. The authors of this chart forgot to include amines in amides.